All right, topics in math, permutations and combinations. So yesterday, I'm looking at page 5 here. We talked about permutations and how we could take in things, take an r at a time in PR. That would be n factorial over n minus r factorial. Okay, today the combination. So going back to permutation, this is when the order matters. So if you're putting in like a code or trying to rearrange the letters in a certain order or figuring out who gets first, second, third, that's when you use the permutation. The one we're going to look at today is combinations when the order doesn't matter. Okay, so let's go ahead and look at page 6 on the combinations. So for the combination, again, this is a group of objects when the order doesn't matter. For example, if we look at this first one, Natalie has 16 friends and she wants to figure out 5 bridesmaids. So she's figuring out of her friends, which one should she let be her bridesmaids. Okay, so the order doesn't matter on how she chooses them. Now, maybe down the line it would matter, but right now she's just picking 5 bridesmaids. So how this is going to be set up in CR equals, still the top remains the same, n factorial. And then when you divide it, however, since the order doesn't matter, we are going to first take that r by itself, r factorial, and then subtract them like we did on the permutations, n minus r. So r factorial times n minus r. Okay, and remember, if you have NCN, this time it's just going to equal 1. So that one's going to be a little bit different than NPN. All right, so Natalie's got the 16 friends, so she's going to have 16 taken 5 at a time. So how this looks is we're going to go 16 factorial, the big number on top, over the other number by itself, 5 factorial, and then subtract them, 16 minus 5 factorial. So you go 16 factorial over 5 factorial times 11 factorial. So now we want to think of which one is the bigger number on the denominator. That's the one we're going to cancel with the numerator. So if you think of 16 factorial, remember that meant 16 times 15 times 14 times 13 times 12 times 11 factorial. So you want to go down to that bigger number. The 5 we're going to have to do a different way, but the 11 we can do that way. So in the denominator, that 11 factorial will end up canceling out with that 11 factorial in the numerator. However, the 5 does not cancel out. So we still have it over 5 times 4 times 3 times 2 times 1. So then in your calculator, what you want to do is multiply it all the top and either push equals and then divide it by the bottom. But regardless, you're going to have to put the bottom numbers there in parentheses. All right, so now we can go ahead and calculate 16 times 15 times 14 times 13 times 12. Those 11 factorials canceled. So if we do that, and you can do this on your calculator all in one step, but if you just wanted to do the numerator there, I got 524,160. And then now divide it by 5 times 4 times 3 times 2 times 1, which was 120. Or like I said, if you put it in parentheses, you can do it all in your calculator at once. And if you divide that, you should get 4,368 ways. So that's how many ways, if she had all those friends and she was trying to figure out who to have be her bridesmaid where order didn't matter, that's how many ways she could come up with it. All right, next one. There are 24 students in Kyle's kindergarten class. How many ways can he choose 8 to attend his birthday? So again, it doesn't matter which one is picked first, or the order doesn't matter. We're just inviting 8. We're sending 8 invitations out. So it's going to be 24C8. So why don't you guys try to set up that equation? What would that look like if it's a combination where order didn't matter? All right, so remember that big number goes on top, 24 factorial. The small number goes on bottom, and we have to also subtract them like we did on the front of the worksheet. So 24 minus 8 would be 16. So again, 16 is the bigger number, so we're going to take that numerator, 24 times 23 times 22 times 21 times 20 times 19 times 18 times 17 times 16 factorial. And then over that 16 factorial, again, those two will cancel, but what doesn't cancel is that 8 factorial. So we have to leave that 8 times 7 times 6 times 5 times 4 times 3 times 2 times 1 in the denominator. All right, so now you can multiply the numerator in parentheses and then divide by the denominator. Again, the denominator, make sure you put those parentheses. If you do the top, you can just push enter and then divide it by, but you've got to do parentheses in the bottom if you want to do it all at one step. All right, so if we do that, there should have been 735,471 ways to invite the 8 kids to the birthday party. All right, why don't you guys try, let's see. Okay, go ahead and try the last 3 here, and then I'll help you set them up if you don't have it figured out. So go ahead and pause the video, try 14, 15, and 16. All right, let's take a look at those last 3. Now, the next thing we're going to need to be able to do is figure out if it's a permutation or a combination. So let's try to think about why are these combinations. All right, she is adopting kittens from a pet store. There's 18 kittens, and she wants to pick 2. So let's say she wants the orange one and the spotted one. It doesn't matter if she picks the orange one and then the spotted one, or the spotted one and then the orange one. She's going home with 2 kittens. So that's why it's a combination. Okay. All right. So I set that one up. 18 factorial over 16 factorial and 2 factorial. It doesn't matter the order of this denominator. So 16 was that big one. So that's what I'm going to be able to cross off. So now I'm just left with 18 times 17 all over 2 times 1 is 2. And if you want, before you grab that calculator out, you can even simplify this further and just take a 2 out of both those and just take 9 times 17. If you didn't do that step, you can take 18 times 17 and then divide it by 2. So it should have been 153 ways how she could pick 2 from the pet store. All right, 15, 12 employees at the sub shop. How many ways can the manager choose for the Sunday evening shift? So again, it doesn't matter if you get chosen first to work that shift or if you get chosen last. They're choosing 4, okay, where order does not matter. So on the numerator, we're going to do 12 times 11 times 10 times 9, and then 8 factorial was our biggest number on the bottom. So we'll leave that 8 factorial, but then we're left with 4 times 3 times 2 times 1. So again, those 8s can cancel. And then just different things, if you want to simplify as you go, instead of typing it on your calculator, you could simplify like 4 and 3, you could cancel the 12 out. The 2 and the 10 could simplify to be 5. I'm guessing you guys aren't going to do that, so I'm going to erase that and do it how you guys will probably do it. I'm guessing you guys will just multiply the tops, 12 times 11 times 10 times 9. And either write it down or keep it in your calculator. 11,880. And then divide by parenthesis 4 times 3 times 2 times 1. Or what's that? 24, right? Which is 495. So 495 ways to choose the people that work the Sunday evening shift. All right, the last one. There are 85 players on the football team. How many ways can the coach choose 3 to represent the team in the coin toss? So 85 taken 3 at a time. 85 times 84 times 83. And then the 82 factorials are going to cancel out. So then it's over 82 factorial, and then 3 times 2 times 1. That would be 3 factorial. So that 82 factorial, those cancel, but then we still have 3 times 2 times 1, or just 6 on the denominator. So we're going to do the numerator, 85 times 84 times 83, divide by 6. Okay? And we should get 98,770 ways you could pick 3 people out of 85 people. Okay, where order doesn't matter. All right, so what I want you to do, I want you to work on the Khan Academy. We had one yesterday, and now we had 2 yesterday and 1 today. So the 3 Khan Academies. One is the counting principle. One is permutations. And one is combinations. If you haven't been here, on the front of the packet, all those formulas are in that glossary. So if you're not sure what the permutation formula is, you can just go to that glossary, look there. And then if you get all of that done, what I want you to do is start working on the next page. All I want you to do is pick if it is a combination or a permutation. So if you're done with Khan Academy, on page 7, choose C or P. So in that middle column, you're just choosing, is it a combination or a permutation? So if I'll go look at that assignment here real quick, just to show you guys what I mean. Okay, so if I go to that page 7, looks like this. So what I want you to do, you don't have to find the answer yet. We'll work on that the next day, but just figure out, is it a permutation or a combination? Does order matter, permutation, or not matter, combination? So like for this first one, you're choosing 4 candy bars from a store that sells 30. Does it matter if I choose the Twizzlers first and then the Hershey's, or I'm just choosing 4? So think about if the order would matter on that one. The order would not matter. So that would be the combination. Okay. Number 2, how many ways can 13 students line up for lunch? The order matters. Who gets to be the line leader? That's going to change every different time you calculate that. So that's going to be a permutation. Okay. Remember, the order matters. It's a permutation. If the order doesn't matter, it's a combination. We'll do 2 more, and then you guys can work on the rest of them. All right, this one, you're trying to make 3-letter arrangement out of the word trapezoid. Order matters here. So again, it's a permutation. That's like what we did a couple days ago, or yesterday, I guess. And then the next one, how many ways can you choose 2 books from a shelf of 40 books? So you're at the library, you're picking out 2 books. Does it matter the order? No, it does not. So that'd be a combination. So just try to fill in that column, and then we'll work on calculating them the next day. Okay, so you're working on Khan Academy, those 3 activities, and then if you're done, page 7. Let me know if you have any questions.